بسم الله الرحمن الرحيم. التسجيل 38 من كتاب 1300 قانون في الرياضيات. and non-exact otherwise and non-exact otherwise and non-exact otherwise. The general solution is integral mxy dx plus integral nxy dy plus integral nxy dy plus integral nxy dy equal c. 1170 radioactive dψ dy on dt equal minus ky, dy on dt equal minus ky, dy on dt equal minus ky, where yt is the amount of radioactive element at time t, radioactive element at time t, radioactive element at time t. K is the rate of decay. K is the rate of decay. K is the rate of decay. The solution is yt equal y0 e power minus kt, y0 e power minus kt, y0 e power minus kt, where y0 equal y0, where y0 equal y0, where y0 equal y0 is the initial amount, 1171 Newton's law of cooling. dt on dt equal minus k t minus s minus k t minus s minus k t minus s, where t is the temperature, where t is the temperature of an object at time t. S is the temperature of the surrounding environment. K is a positive constant. The solution is t equal s plus t 0 minus s e power minus kt, t equal s plus t 0 minus s e power minus kt, t equal s plus t 0 minus s e power minus kt, where t0 equal t0, where t0 equal t0, where t0 equal t0 is the initial temperature of the object at time t equal 0. The object at time t equal 0. The object at time t equal 0. population dynamics logistic model. dp on dt equal kb 1 minus b on m, kb 1 minus b on m, kb 1 minus b on m, where bt is population at time T K, where beta is population at time T K, where beta is population at time T K, is a positive constant, is a positive constant, is a positive constant. M is a limiting size, M is a limiting size, M is a limiting size for the population, for the population, for the population. The solution of the differential equation is, the solution of the differential equation is, the solution of the general equation is beta equal MB 0 on, beta equal MB 0 on, beta equal MB 0 on, B0 plus n minus B0 e power minus kt, B0 plus n minus B0 e power minus kt, B0 plus n minus B0 e power minus kt, where B0 equal B0, where B0 equal B0, where B0 equal B0 is the initial population at time t equal 0, is the initial population at time t equal 0, is the initial population at time t equal 0. Second order ordinary differential equations, second order ordinary differential equations, second order ordinary differential equations. 1173 homogeneous linear equations with constant coefficients. Homogeneous linear equations with constant coefficients. Homogeneous linear equations with constant coefficients. Second derivative y plus, second derivative y plus, second derivative y plus, b derivative y, b derivative y, b derivative y, plus q y equal 0, plus q y equal 0, plus q y equal 0. The characteristic equation is, the characteristic equation is, the characteristic equation is lambda square plus b lambda plus q equal 0, lambda square plus b lambda plus q equal 0, lambda square plus b lambda plus q equal 0. If lambda 1 and lambda 2 are distinct real roots, if lambda 1 and lambda 2 are distinct real roots, if lambda 1 and lambda 2 are distinct real roots of the characteristic equation, of the characteristic equation, of the characteristic equation, then the general solution is, then the general solution is, then the general solution is y equals c1 e power lambda 1x, y equals c1 e power lambda 1x, y equals c1 e power lambda 1x, plus c2 e power lambda 2x, plus c2 e power lambda 2x, plus c2 e power lambda 2x, where c1 and c2, where c1 and c2, where c1 and c2 are integration constants, are integration constants, are integration constants. If lambda 1 equal lambda 2 equal, if lambda 1 equal lambda 2 equal, if lambda 1 equal lambda 2 equal minus b on 2, minus b on 2, minus b on 2, then the general solution is, then the general solution is, then the general solution is y equals c1 plus c2x e power minus b on 2x, y equal c1 plus c2x e power minus b on 2x, y equal c1 plus c2x e power minus b on 2x. If lambda 1 and lambda 2 are complex numbers, if lambda 1 and lambda 2 and are complex numbers, if lambda 1 and lambda 2 are complex numbers. Lambda 1 equal alpha plus beta I, lambda 1 equal alpha plus beta I, lambda 1 equal alpha plus beta I, lambda 2 equal alpha minus beta I, lambda 2 equal alpha minus beta I, lambda 2 equal alpha minus beta I, where alpha equal minus b on 2, where alpha equal minus b on 2, where alpha equal minus b on 2. Beta equal root 4q minus p square on 2. Beta equal root 4q minus p square on 2. Beta equal root 4q minus b square on 2. Then the general solution is y equal e power alpha x, y equal e power alpha x, y equal e power alpha x, c1 cosine beta x, c1 cosine beta x, c1 cosine beta x, plus c2 sine beta x, plus c2 sine beta x, plus c2 sine beta x. 1174 in homogeneous linear equations with constant. In homogeneous linear equations with constant. In homogeneous linear equations with constant. Coefficients. Second derivative y plus b derivative y. Second derivative y plus b derivative y. Second derivative y plus b derivative y. Plus qy equal fx, plus qy equal fx, plus qy equal fx. The general solution is given by y equal y p plus y ash, y equal y p plus y ash, y equal y p plus y ash, where yp is a particular solution, where yp is a particular solution, where yp is a particular solution of the inhomogeneous equation, of the inhomogeneous equation, of the inhomogeneous equation. And y ash is the general solution, and y ash is the general solution, and y ash is the general solution of the associated homogeneous, of the associated homogeneous, of the associated homogeneous equation. See the previous topic. See the previous topic. See the previous topic. 1173. If the right side has the form. If the right side has the form. If the right side has the form. Fx equal e power alpha x. Fx equal e power alpha x. Fx equal e power alpha x. b1x cosine beta x. b1x cosine beta x. b1x cosine beta x plus b1x sine beta x plus b1x sine beta x plus b1x sine beta x. Then the particular solution. Yp is given by yp equal x power k e power alpha x. Yp equal x power k e power alpha x. Yp equal x power k e power alpha x. r1x cosine beta x. r1x cosine beta x. r1x cosine beta x plus r2x sine beta x plus r2x sine beta x plus r2x sine beta x, where the polynomials r1x and r2x, r1x and r2x, r1x and r2x have to the found by using the method of undermined, by using the method of undermined, by using the method of undermined coefficients. If alpha plus beta I is not a root of the characteristic equation, is not a root of the characteristic equation, is not a root of the characteristic equation, then the power k equals 0, then the power k equals 0, then the power k equals 0 if alpha plus beta I is a simple root, if alpha plus beta I is a simple root, if alpha plus beta I is a simple root, then k equal 1, then k equal 1, then k equal 1. If alpha plus beta I is a double root, is alpha, if alpha plus beta I is a double root, if alpha plus beta I is a double root, then k equal 2, then k equal 2, then k equal 2. 1175 differential equations with y missing, differential equations with y missing, differential equations with y missing. Second derivative y equal, second derivative y equal, second derivative y equal if y derivative, if x derivative y, if x derivative y, if x derivative y. Set u equal derivative y, set u equal derivative y, set u equal derivative y. Then the new equation satisfied by, then the new equation satisfied by, then the new equation satisfied by v is derivative u equal, v is derivative u equal, v is derivative u equal fxu, 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 which is a first order differential equation, which is a first order differential equation, which is a first order differential equation. differential equations with x missing, differential equation with x missing, differential equation with x missing. Second derivative y equal, second derivative y equal, second derivative y equal if y derivative y, if y derivative y, if y derivative y. Set u equal derivative y since, set u equal derivative y since, set u equal derivative y since second derivative y equal du on dx, second derivative y equal du on ds dx x, second derivative y equal du on dx equal du on dy equal du on dy equal du on dy, dy on dx, dy on dx, dy on dx equal u du on dy equal u du on dy equal u du on dy. We have u du on dy, u du on dy, u du on dy equal fu equal fyu equal fyu equal fyu, which is a first order differential equation, which is a first order differential equation, which is a first order differential equation. 1177 free undamped vibrations, free undamped vibrations, free undamped and damped vibrations. The motion of a mass on a spring, the motion of a mass on a spring, the motion of a mass on a spring is described by the equation m second derivative y plus ky equal 0, m second derivative y plus ky equal 0, m second derivative y plus ky equal 0, where m is the mass of the object, where m is the mass of the object, where m is the mass of the object, k is the stiffness of the spring, k is the stiffness of the spring, k is the stiffness of the spring. Y is displacement of the mass from equilibrium, the mass from equilibrium. The general solution is y equal a cosine epsilon 0 t minus delta. Y equal a cosine y equal cosine omega 0 t minus delta. Y equal a cosine omega 0 t minus delta. Y equal a cosine omega 0 t minus delta, where a is the amplitude of the displacement Omega 0 is the fundamental frequency. Omega 0 is the fundamental frequency. Omega 0 is the fundamental frequency. The baroid is T equal 2 pi on omega 0, 2 pi on omega 0, 2 pi on omega 0. T equal 2 pi on omega 0. T equal 2 pi on omega 0. T equal 2 pi on omega 0. Delta is phase angle of the displacement. Omega is the phase angle of the displacement. Omega is the phase angle of the displacement. This is an example of simple harmonic motion. This is an example of simple harmonic motion. This is an example of simple harmonic motion. 1178 free damped vibration, free damped vibrations, free damped vibrations, free damped vibrations. M second derivative y plus, M second derivative y plus, N second derivative y plus, gamma derivative gamma, gamma derivative gamma, the gamma derivative wait, gamma derivative y, gamma derivative y, gamma derivative y, plus ky equal 0, plus ky equal 0, plus ky equal 0. Gamma is the damping coefficient. Gamma is the damping coefficient. Gamma is the damping coefficient. There are three cases for the general solution. There are three cases for the general solution. There are three cases for the general solution. Case 1. Gamma square bigger 4 km. Gamma square bigger 4 km. Gamma square bigger 4 km over damped yt equal a e power lambda 1t, yt equal a e power lambda 1t, أعيد yt equal a e power lambda 1t plus b e power lambda 2t plus b e power lambda 2t plus b e power lambda 2t, where lambda 1 equal minus gamma minus root gamma square minus 4 km on gamma square minus 4 km on gamma square minus 4 km on 2m gamma 2 lambda 2 equal minus gamma plus root equal minus gamma plus root equal minus gamma plus root gamma square minus 4 km on 2m root gamma square minus 4 km on 2m root gamma square minus 4 km on 2m. Case 2 gamma square equal 4 km gamma square equal 4 km gamma square equal 4kn critically damped yt equal a plus bt e power lambda t yt equal a plus bt e power lambda t yt equal a plus bt e power lambda t, where lambda equal minus gamma on 2m, where lambda equal minus gamma on 2m, where lambda equal minus gamma on 2m. Case 3 gamma square less 4km, gamma square less than 4km, gamma square less than 4km, gamma square less than 4km. إذن هي less than under damped yt equal e power minus gamma on 2mt minus gamma on 2mt minus gamma on 2mt a cosine omega t plus delta a cosine omega t plus delta a cosine omega t plus delta, where omega equal root 4km minus gamma square 4km minus gamma square 4km minus gamma square 1179 simple pendulum d square theta on d t square d square theta on d t square d square theta on d t square plus g on l theta equal 0 plus g on l theta equal 0 plus g on l theta equal 0, where theta is the angular displacement, where theta is the angular displacement, where theta is the angular displacement. L equal the pendulum, L equal the pendulum, L equal the pendulum. Length, G is the acceleration of gravity. G is the acceleration of gravity. G is the acceleration of gravity. The general solution for small angles theta is the general solution for small angles theta is the general solution for small angles theta is theta t equal theta max sine root J on LT the baroid is T equal 2 by root L on J 2 by root L on J 2 by root L on J 1180 RLC circuit L d square I on d t square L d square I on d t square L d square I on d t square plus R d I on d t plus R d I on d t plus R d I on d t plus 1 on C I plus 1 on C I plus 1 on C I equal derivative VT equal omega epsilon 0 cosine omega t equal omega epsilon 0 cosine omega t equal omega epsilon 0 cosine omega t equal omega epsilon 0 cosine omega t. Where I is the current, in an RLC, circuit with an AC, voltage source VT equal إبسلون 0 ساين أوميغا تي إبسلون 0 ساين أوميغا تي إبسلون 0 ساين أوميغا تي. صلى الله تبارك وتعالى على سيدنا محمد وعلى آله وصحبه أجمعين، والحمد لله رب العالمين.